Okay, so first things first, let's go ahead and kind of add into our function these choices, right? The choices that individuals are making. So what I'm going to do is I'm going to create some space to work here at the top of our function. You'll keep in mind, again, I'm just tabbed over one. So typing here would result in an error. Typing here means that it's a part of the function. So I'm going to be working in that particular space. So within here, the first thing we're going to do is within the actual function itself, we're going to go ahead and load in the data frame. So you'll remember last time we loaded in the data frame outside of the function and then passed it into the function. You can do that. There's no real reason not to do that, but this will just make things a little simpler. So I'm going to copy this data load and I'm going to put it right here. And I'm going to go ahead and call this the same thing as before, nn_data frame. Now, because we're loading this inside of the function, we no longer need it here, right? So when we defined our function, we were originally asking for the user to pass in the data frame. Let's go ahead and get rid of that. So we're going to delete that. So now we just have our preferred unemployment and our preferred salary. Now, what we do want to do, though, is add in to this the choices. So we're going to do comma choices, or let's do comma topics to make this easier to understand. So now we have this new thing, which is topics. So down here in our nearest neighbor function, right, this is where we actually call our function. First and foremost, we have to get rid of this because we no longer have the data frame being loaded in. We're loading it locally within the function. And then second, we need to actually pass in the topics that an individual chooses. So we're going to go ahead and do topics equals choices. And so we're going to set topics equal to this set of choices that a user makes. Again, you're probably still thinking, why are you doing this in a function? Why not just do it in code? I swear we'll get there. It's just taking a little while. So now we have our data loaded, and we actually want to make it so that we're only looking at the topics they're interested in. And this is pretty straightforward. We're going to do the NNDF, so we'll take our data frame, and we're going to set it equal to that data frame with only the topics that we're interested in. So this is going to be just like we did before when we were creating our scatter plot with a limited number of different topics. We're going to do that, the major category, so major category, and then that same is in, and we'll do topics. So this will say to take the nearest neighbor data frame and essentially redefine it as the same thing, but with only those rows that have a major category in the list topics, which we are calling choices here. When we call the function, we set topics equal to choices, so topics becomes this list. Oh my goodness, I swear it makes sense. Bear with me. Okay, so that was two of our problems right off the bat. Now we are actually subsetting our data down correctly, and we are kind of passing all of that information in correctly as well, the topics information. But you'll remember when we ran this earlier, our distances are enormous because we're weighting our dollar dimension much, much higher than our unemployment dimension. So if someone is $1 away, that's a huge difference compared to the unemployment rate of being 1% away. We just have to normalize those. So we're going to do this in a very, very simple way. What we're going to do is we're going to take the unemployment rate and we're going to redefine it as the unemployment rate divided by the maximum unemployment. And the same thing for dollars. We're going to say every single one is going to be the dollar value divided by the maximum dollars. And so that way our dollars and our unemployment rate will both all be values that range between 0 and 1. So when we calculate distances based on those, the distances themselves won't be skewed. They'll actually be on the same scales. That said, we don't, the end user for this particular model shouldn't need to know that, right? We don't actually want them to be aware that that is something that they need to worry about. So we're also, in addition, going to save information on kind of the raw data itself. So first, let's just save. So let's say the max or the pref unemployment display value, and we'll set that equal to pref unemployment. And then we'll have the pref sal display, and that'll be pref salary. And again, all we're doing here is we're saving the original pref unemployment and pref salary that the user gives us. So this pref unemployed display, that's going to be set to 0.05. Pref median salary is going to be set to 100,000 in this case. So now what we want to do is that normalization. So we're going to go ahead and I'll just add a comment here. So normalization, just so we remember where we are, because this code is getting a little bit complicated. And we're going to go ahead and reset so that the user options themselves, we have to scale those as well. So the pref unemployment That's going to become pref unemployment. This is what the user tells us, divided by the unemployment rate dot max. So we're going to say, okay, within the data frame that we're looking at, find the maximum unemployment rate and divide the user's preferred unemployment by that value. This will scale this to a value between 0 and 1. So when we put, so let's say a user wants to be 0.05 and 100,000. This is their kind of point of interest. That needs to be rescaled to the new dimensions we're using to normalize the unemployment rate and the salary. We're going to do the same thing for the salary. So salary. You'll remember median is the name of the salary. So same thing. We're just dividing those out. Now we have to do the same thing to the data itself. So here all we've done is normalize the user's options, which is the preferred unemployment and the preferred salary. Now we need to do the same thing to every single row of our data. So we don't want the median salary to be 50,000. We want the median salary to be something between 0 and 1. We want an employment rate to be something between 0 and 1, so that when we calculate distances, it actually makes sense. So how we're going to do that is also fairly straightforward. We're going to take our data frame, and we'll take the unemployment rate, and we'll create a new column called distance. So it's just, we're only going to use this for the distance calculations. That's going to equal there we go. So this is exactly what it looks like. We're creating a new column of data called unemployment rate distance. And for every row, it's going to be that row's unemployment rate divided by the maximum unemployment rate. So we're going to be standardizing the data. And do the exact same thing for our median income. And there we go. So now everything is standardized. Now down here, when we calculate our distances, we just have to make sure that we're using these new formulas. So we're going to use the unemployment rate distance here and the median distance here. And then you'll remember pref unemployment. When we write here, we actually have normalized that variable pref unemployment, pref salary. We've normalized that here. So now we're taking the normalized values and we're subtracting these other values for them. And we're still going to return this nearest neighbor data frame. So let's take a look and see what we get. So here's our new data frame. You'll see that we are now going to be limited to the humanities, social scientists, and computer and mathematics, right? So we've now subset our data. And if we go all the way to the right, you'll see all of these distances are now within reasonable ranges. We no longer have enormous values being caused by the kind of value of the dollars. It's all been normalized. So now all we want to do to get this function actually complete is to order these so that we're only taking the 5 smallest distances. So in this particular case, instead of returning NNDF, which is the entire thing, what we're going to do is NNDF.smallest, or n smallest rather, 5, distance. And this will take the 5 smallest values of distance and return them to us. So run that, and here we go. Statistics and data science, information science, math and computer science, computer science. This is the set that had the smallest distances from our target point. Okay, so let's see if this algorithm and its outputs actually match our intuition. So first, let's go up to our chart. Now, one thing you'll remember is on our y-axis, we're actually plotting the 75th percentile, and here we're using the median salary. So let's just change this figure real quick to be the median instead. So my y-axis, all I've done on my scatter is change that to median. Everything else is the same. Go ahead and run this. You scroll up, so this is the median salary kind of picture. So if we run this down here, let's say we want a preferred unemployment rate of 0 and a median salary of $200,000. So, kind of like our default. Go ahead and run this. And so we have mathematics and computer science, applied math, stats, and information science. Let's remember these 5. Go up here. Our hypothetical was 0 and 200,000, so we put a point somewhere way up here. The first one, math and computer science. Second one, computer science. information sciences, applied mathematics, stats, and decision science, right? So we can see the 5 points closest to a hypothetical up here are what we found. But let's actually test something else. Let's say that we want a social science job with an unemployment rate of 0.07 and a median salary of around $60,000. And we would expect political science and government to be one that comes up here. So 0.07 and 60,000. Let's go ahead and run this. Here we go. Political science and government and international relations, followed by geography, which is my own degree. So we have a point right here, and we've actually gone through and we found that these are the 3 closest points to that hypothetical that we had right here. So our algorithm's working. It's doing exactly what we might expect. In the next video, what we're going to do is we're going to take this algorithm and actually wrap it in a really lightweight user interface that would allow kind of lay people to actually use this algorithm to quickly get these types of results.